Well, hello everyone. It's January the 13th. Right before this, I just watched some Clarence. God, dude, just. I think I watch all his videos. But no, from time to time you go back to his outrageous ones. Like his deadlift one, 340 kilos. My lord. 330 kilos without strap. And also watched his 200 kilos bench. Close grip. You look at that, he's like, wow, that's a specimen. I haven't even gone into his tricking videos. That is a specimen. 1 in a billion. I don't know. I got hurt. I hurt myself a little bit this week training. Pushed a bit harder than I supposed to. Yeah, it's just with me, the lifting problem is always the degradation of technique. Like I'll figure out a technique for a while and then I'll lost it. Yeah, that's the worst feeling. Alright, anyway, so this is what we have today. Lexicographically, smallest equivalent string. You're given 2 strings of the same length and a string base string. We say these are S1i and S2i are equivalent characters. For example, this and this, we have A equal to C, B equal to D, and C equal to E. Equivalent characters follow the usual rule of any equivalence relationships. Reflexive symmetry, transitivity. Okay? For example, given the equivalence information, this and this, they're equivalent. This and this are equivalent strings of base string because A equals C, B equals D, so BD is the same, AC is the same, and the C also equal to E, so ACE are all the same, right? So ACE, so AC, and then B is D, yes, so the base string EED, so this one, they're all equivalent strings of this. And AAB is the lexicographically smallest equivalent string of this. Return the smallest equivalent string by using the equivalence information from S1 and S2. Okay, so Parker Morris. Who's Parker Morris? Oh, Morris Parker. So P and M is the same. So we do M, A. A will always be A. R can be K because R can be K. S can be R. Oh, hold on. S can be, R can be K. Yeah, E is E. And R is maybe macaque. So, most likely, this is going to be union fine because equivalency means they belong to the same union. So in a union, all of these, right? And then we get union out. And we just, in the union rule, when we find its parent, the parent is going to be the smallest. The parent is going to be the smallest. That shall do. Now take a look. It's an interesting question. If you don't know union find, actually I don't know how you can solve this. But this one will have slight difference in the union find in terms of finding a parent. So let's try it. DSU, right? What parent usually is range. I mean, these are letters. Letters, they are range, so it's fine. It's fine. So be list range n, right? So n is going to be 26, right? N is going to be 26. That's okay. That's okay. Oh, okay. Self.rank. Rank. Whoever has the smallest shall have a higher rank. Okay, so the rank is going to be 0 times n. to start with. Def find. Find is nothing specific. If self.parent x is not equal to x, self.parent x equals self.find self.parent x. Return self.parent x. Right, def union x y. Templating value px py self.parent x self.parent y. If px is equal to py, return false. Otherwise, if self.rank px larger than self dot, oh, that's now what we're gonna do. Rank. We need to change this. So the rank starts as the same, and then I can assign the one with higher to be higher, right? So it shall be, so x and y, right, their parent. So we look at their parent, and the smallest parent shall be assigned. Maybe we don't even need parent, need rank. All we need here is who is smaller, right? Can we just say if px is smaller than py, then self.parent py equals px. Right? If it's the same, so it could be this, else self.parent px equals py. I think this shall do, right? We don't even need a rank because there's no ranking. Ranking is based on the lexicographical, right? And then we are English letters. So what we're gonna do is DSU equals DSU 26 letters, and then for A, B in zip S1, S2, right? And DSU dot union ord A minus, is that 60, 67? 96. Jesus. 96. Oh, I can do, it's all lowercase, right? Yeah. DS, oh, it's not done yet. Ord B minus ord B. Minus ord A. Okay, so we do that, and then we go base. Then we say we're gonna return, right? Dot join for a letter in base string. We're gonna do DSU dot find letter, and we're gonna do character this plus 97. I just do 97. Come on. You know what this is. Okay. Let's give this a shot. It's like everyone we got is the smallest possible. I think as long as the DSU is correct, I don't see how this one will not be correct. Okay. S1, S2, base str, smallest S1, S2. That's interesting. Oh, letter. You cannot find a letter. Oh, that is ugly. A-U-A-C. Where did you get C from? Interesting. I see. Should be A-A-U. I do A, C. C shall be connected to A. How is C connected to A? LeetCode C connect to R. R connect to E. E connect to S. Really? E and A. E to R. E to O. T G. C R. A O. Oh yeah, A and O. A and O. How? I probably need to go through them once. 26. Yes, you that find. I. No. No. Which means that we have some issues here. Hold on. Why do we have this problem? Print dsu dot parent. That is not helpful at all. Yeah, it's not 0. C is 2 because C gets connected to R, but R is already connected to E. Huh. Hold on, so I need to return true. That's fine. Alright, so I think what happens when these two I shall resolve this problem, right? When the parent is the same. Wait, hold on. Let's take a look. The union has some issue. X, Y, PX and PY. Let's take a look. So X, nah. Okay, so LP is fine. RE. No, actually shalt. No, it should be at the end. Self the parent X. Oh, my bad. It's not self.parent. Dang. I was like, it doesn't work? Of course it does. Got it wrong. Find. Okay. Yeah, I mean, you know how to do it, it's very fast. But if you don't know, I guess it'll take a while. But good, you know, practice union find. Yeah, it's one of those problems that's it's much easier if you know how to do it. I was one of the people who never know how these things work. So that the parent always prefers a smaller letter. ON, and I think it's A. It's reverse Achman, something like that. Who knows? DFS. Yeah, union fine. Oh. What's a sigma? Number of unique characters. Oh. Log sigma, whatever this is. So M is len s1, N is len base, sigma is the number of unique characters. According to the solution, but why? Didn't use union by size and only have the path compression. Huh. But we do have path compression, right? Don't use union by size. You never use union by size. Alright, whatever it is, just don't care. It's too complicated. I'm happy with this. Alright. I say it's log. I don't know. Ah, I got this one. That's good enough. Move on. Total cost to hire K workers. They're given a zero indexed integer array costs, where costs I is the cost of hiring the ith worker. You're also given two integers. Okay, you're given integer k and candidates. We want to hire exactly k workers according to the following rules. You'll run k sessions and hire exactly one worker in each session. In each hiring session, choose the worker with the lowest cost from either the first candidate's workers or the last candidate's workers. Break the tie by the smallest index. For example, if cost is this, candidates is 2. Then in the first hiring session, we will choose the fourth worker because they have the lowest cost. In the second hiring session, we will choose the first worker because they have the same lowest cost as the fourth one, but they have the smallest index. What's K? K is sessions. What's candidates? The first candidate's workers, okay. The indexing may be changed, of course. Fewer than candidates worker remaining. Choose the worker with the lowest cost. Worker can only be chosen once. Return the total cost of hiring exactly k workers. Okay, so given this, we have what, 17, 12, 10, 2, 7, 2, 11, 28. So we do 3 rounds. Each round we can pick 4. So we have 1, 2, 3, 4 in the front, 1, 2, 3, 4 at the back. And then we pick the smallest. Well, we pick this, so it'll be 2. Next round, 4. Smallest will pick this. Next, what about overlapping? I guess overlapping doesn't matter, right? Oh yeah, you can have overlapping. So 1, 2, 3, 4. 1, 2, 3, 4. So we choose this. That's 11. Okay. All right, and this is 3. So 1, 2, 4, 1. 1, 2, 3. 1, 2, 3. So this is the first one chosen. Next one I have 3, so we choose this. The third one choose this, so it's 4. Okay, so we have an array. We have first first candidate, next candidate. Okay, and because we choose something and then we just move to the right, so we can keep the smallest. Ooh, no, it's not keeping the smallest. It's we're gonna have a heap on the left side and heap on the right side, and then we peek at the top of the heap, pick the one the smallest, add it, and then this one gonna add one more, right? And then keep doing this, can only choose once, so we have to make sure when they overlap, when they start to overlap, it's okay. When they start to overlap, oh, So before overlapping, it's fine. We just 2 heap. That's fine. But when they overlap, right? When they overlap, so one of them get into the territory of the other. So when that happens, are we saying one of them just stops moving? Right? Okay. If it goes into the other, one of them just stops moving. Because this doesn't really matter. Right? And then we exit. And then, yeah, that's fine. We still have 2. We just continue with 2. Right? When they touch each other, we just don't move. And then we find the smallest. And then we just pop. We don't move. It's not necessary to move. And then, but it might mean that we have to do it twice. Right? We have to pop it twice. No, you only pop it once. You only do it once. Yeah, I think it's fine. It shall work. Shall work, man. Shall work. Just 2 heap, and both are gonna be main heap. So we can say heap left, heap L, and heap L will equal to, oh, well, yada yada yada. Okay, so the K can be, no, the candidates can be huge. So let's do it this way. N equals len costs, right? If candidates is larger or equal to n, right, we're gonna return sum sorted costs. As we can pick whichever we want. Right, we're gonna sort them, take the first K. That's it. Right? If candidates is more. Otherwise, because we get small one time, you know, it's just, I don't feel it. Right? I don't feel it. Otherwise, we can say heap left equals, oof, when they overlap at the beginning. That's fine. That's fine. So what we're gonna do is just heap left equals, we take the first candidates among them, right? So I in range to candidates, we're gonna do costs I and I, right? So that's that, and heap right shall equal to from this up until how do we do this? Heap left and I'm gonna say L also equal to candidates minus 1. That's L. And a right shall be same thing, right? Costs, I call it I. Right, I'm gonna say cost J, with J in range, candidates minus, no, candidates minus 1, n minus 1 towards something. What's this something? Well, we shall take candidates, right? So we shall take candidates. So n minus 1, so n minus candidates. Actually, I don't know. Hold on. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, 9. So that's a 1, 2, 3, 4. So 0, 1, 2, 3, 4, 5. So position is 5. So 9 minus 4. Right, because this one is 8. Position is 8. 1, 2, 3, 4. So we do this. So n minus 1 minus candidates, right? So n minus 1 minus candidates. But we have to do the maximum of this And because the candidates, right? The candidates can pick into a certain position. So candidates -1. Because candidates -1 you cannot take. You can take the one before it. So that's that. And j shall equal to, I don't like this. I do not like this. All right, let's say low. How about low? So low is going to be candidates -1. Okay, so all the way to low +1. High is going to be maximum this. Well, it's going to maximum n minus this or candidates, right? That's on the high, the bigger of the two. So here is going to be high -1. That's more likely. Okay, of course, also we have say heap q dot heapify heap l heap q dot heapify heap r. Okay, so we have a low and a high, and then we say, what do we say? Rest is 0, right? And then we're gonna say low and a high. They're gonna right? While k, right? We do a k round. So this is the first round. And if the first round, what do? We're gonna check left and check right. Right? We're gonna check left and check right. And what do we say? We just basically say if heap left 0 0 is smaller than heap r 0 0, then rest plus equal to heap q dot heap pop heap l. Right, we pop this, we get the 0, and then we say if low is smaller than, if low +1 is smaller than high, right? So they're not meeting each other, then low plus equal 1, and heap q dot heap push heap l costs low and low. All right, so that's one. If they're equal, right, which means they just cannot move, then we just don't do anything, right? We just don't do anything. And of course, we shall say if, damn, yeah, there are a lot of situations here, because it could be if both exists, if only one exists. I mean, if only one exists, we can say this: if k and heap l and heap right, so it's guaranteed both exists, right? So we can do this. All right, so we do this is, otherwise we don't change. If, so actually I can copy and paste this entire thing. If this is larger than, right, then we'll pop r, and then if this high will minus equal 1, and then r is gonna get a high and a high, right? And then if they're the same, else, if they're the same, then if, holy crap. So if this, or, my god, heap l, left cost, left index equals heap L0. Okay, right cost, right index equals heap R0. Okay, so we say if left cost is smaller than right cost, or left cost is equal to right cost, but and left this is smaller than right this, then we do this. If right cost is smaller than left cost, or these two are the same, and right this is smaller than left this. And it's not possible for these to be the same. So we just need these two situations, all right? Okay, and then once we're done, if this, then basically I can just say else. Yeah, I can just say else. Because else either this has to be larger than this, or they're the same, but this is larger than this. So we can just do else. If and else, right? Once we're done, we are going to say k minus equal 1. So we go back up, back up, back up. Once we get out, we can say while k and heap L, whichever has stuff left, right? Then we just do, because if k is out, then we don't do this. If one of them is out, yeah, we can just do rest plus equal to this, right? And then do the same thing here, R and R. Then we return rest. Okay, let's see. A little bit convoluted, not my favorite, but we can take a look. Costs, okay. Candidates, total cost. Ooh, the second one is not right. I think we're overcounting. You're overcounting. But how is that possible? How is overcounting possible? So we start got 3. The other one only got 1, right? Yeah, the other one should only get 1. I don't understand. Hold on. Let's take a look. Let's see. What is the heap L and heap R? Heap L, heap R. So the first one we pop this. And the second one pop this. That's 2. Right? I pop this, and then coming out, is this. Oh, I forgot a minus. Lord. I don't want to print anymore. There we go. Yeah, let's try this. Yep. 2 heaps. Just n log n. K n log n. K log n. We'll call it K log n. Oh, candidates. There's also candidates. The heap file is. Wait, what's heap file? Heap file is log n. It's complicated. We can say n log n plus k, or that would be log c candidates, right? And then k log c, where n is the length of costs and c is equal to candidates. Okay, shall do it. Min heap, 2 min heap. Why is it so much simpler, huh? That's actually a good way to push. That's also a good way. We always do on the left side first. That makes sense. That makes sense. I don't have to put the I. Okay. Index, because if the costs are the same, always want to pop the left side. Okay, so this is fine. And then we probably, we can do while this. And then we're just gonna do cost I, right? So we do cost I, and then we do cost j. Okay, if I, and then if heap l else math.inf this one's the same. If this heap r else math.inf, if left smaller than this, then we'll pop this. And then we'll push this. Else we'll pop this, and then we'll push this. Okay. Good. Good. This looks nicer. Whoa, faster. Okay. Let me avoid this. That's a good solution. Okay, that'll be it for today. I'll do this tomorrow. I'll see you guys tomorrow. Adios.